This video will continue our discussion of double integration. We have a new problem here. It's this integral over the region R. The region R, I went ahead and drew it. It is just a 1x1 box. I knew I would obsess a little bit, so I just did it before the video. We're going to use what's at the top there. This would be something that it comes up quite a bit, maybe to write down on a note card or something like that. Right, let's get started on this one. I'm going to pull out the 2 that's on top here when I write it down, and I'm going to leave the negative with the y, and you'll see why. So we have the volume of, okay, let's pull the 2 out, but we're going to leave the negative y on top over 2 minus xy. And now we have to decide which one we want to do first. I see we have a fraction. I'd like to deal with the one that just has one variable, so we'll do dx first. So we have, these are all the same, but I still like to write my x's because I want to be in that habit. X is 0 to 1, y is 0 to 1. Right, so let's do a u substitution here, and this one's going to be an interesting one because how it pans out. Let's let the bottom be our u. So we got minus 2 minus xy. When I take the derivative, since we're dealing with x, I do it with in terms of x, partial with respect to x. So the derivative of 2 is gone, but the derivative of xy is a y. So I got a negative y dx. That covers, in our problem, that's going to cover this. Oops, sorry, my highlighters are really small now. I think I need it about there. That's going to cover this thing. Cover this and that. Right? Those two together will be our du. Right? It's going to make our integral much nicer to deal with. Okay, so let's rewrite this. Switch back to my orange. Okay, I got equals 2. And I got y equals 0 to y equals 1. And I'm going to go ahead and reset this up. Okay, I'm going to switch these to u. And these should have terms of y. Can have terms of y. This first one doesn't. If I plug a 0 in for x, I got a 2. If I plug in a 1 for x, I have a u. Keep writing y. U equals 2 minus y. So it's in terms of y. That's going to be okay because our integral after is in terms of y. This is how it cleans up really nicely. I get a 1 over u du dy. Right? This whole thing here is taken by the du. And then the bottom is a u. Right? So this is much easier to integrate now. I have 2, and I have y equals 0 to y equals 1. And then we're going to go ahead and integrate this. I got the ln of, and it would normally be the absolute value of u, but if we're just plugging in u is based on 2 minus y. Y will never be bigger than 1, so I actually don't need this absolute value, completely based on how u is defined. All right, so I just got the ln of u, and I'm going to run that from 2 to 2 minus y, and then we still have a dy. All right, I'm going to plug all that in, keep my integral on the outside. I'm not touching anything there. And I'm going to have ln of 2 minus y minus ln of 2 dy. I don't know if you remember your logarithm rules. If I have a minus between two logarithms, I can divide my arguments. So I'm going to get 2 minus y over 2. If I simplify that, that's 1 minus 1/2 y. So I'm going to go with that. And so I got y equals 0, y equals 1, and I have ln of 1 minus 1/2 y dy. All right, the integral at the very top, I'm going to just rewrite it here. It's not very long. The the integral of ln of x is x ln of x minus x. Let me fix that gross x there. A little better. All right, so I can use this, but the problem is I have something inside. I'm going to do another u sub. I don't want to use u again, so I'm going to use w, which is 1 minus 1/2 y dw. If I take the derivative is negative 1/2 dy, which means that I got negative 2 dw to be dy. Nothing was going to take that negative 1/2. All right, so we're going to go ahead and replace now. I got equals 2. Let's go ahead and plug and change our y's to w's. If I plug in 0, I get 1. so it's w equals 1. If I plug in 1, I get w equals 1 minus 1/2, which is 1/2. And then I got ln, okay, of u. We should introduce that -2, so let me go back. I got to multiply by -2, because we don't need that multiply symbol. And then I'm going to have ln of u du. So this is -4, and I'm going to go ahead and integrate ln. We know what that is. Oh, it's not u, it's w, which means this is also dw. There we go. Everything lines up now. So used to using u. Okay, so that -2 and 2 make a -4. The integral of ln of w is w times ln of w minus w, and then I'm going to run that from w equals 1 to w equals 1/2. The -2 went outside. That's the -4 there. Okay, I'm going to plug all this in now. Two parentheses, because I got to plug in both. I'm going to have 1/2 ln 1/2 minus 1/2. And then I'm going to have minus 1 times ln of 1 minus 1. All right, I'm going to go ahead and start distributing. -4 is going to go here, here, and then also there. And I'm only doing 1, and you'll see why. So -4 times 1/2 is a -2 ln of 1/2 minus, okay, negative and negative is going to make a positive. 4 times 1/2 is 2. This right here is a 0. ln of 1 is 0. So I got a -1 minus a -1, which is a positive 1, times -4 is going to be a, let's be careful with that, 1, -4. Okay, then we go one step further. I got -2 ln of 1/2. I'm going to put that in parentheses, minus 2. That's a great answer. This would have been a fine answer too. I just need to put my constants together when it's like that. That's just built into me. All right. So this integration gets nasty. Here's some techniques to help you get out of that. I'm trying to give some rough integrals. That way I'm not just working all the easy ones out and then I throw you into the ocean with the practice, right? Like and nobody likes that. So I'm trying to give you some decently difficult integrals. We will still do integration by parts. It will pop up here and there. So make sure you still can do that. Trig integrals are very rare. At this point, we can plug trig integrals into our computer. I'd still like you to do it in homework and practice it, but you probably won't see that on an assessment. All right, there we go.